When given any problem, make sure you underline the key terms. So in this problem, you're given that the coin has a velocity of 12 meters per second. You're also given that you want to solve for the total time. Before starting any problem, make sure you write down the 6 variables. They are the initial distance, initial velocity, final velocity, acceleration, and time. Look at your 3 kinematic equations and choose the one that fits best for this problem. In this case, you want to use V equals V initial plus AT. With this equation, you have all of your knowns and only one unknown that you have to solve for. Now, plug in your givens and solve for time.
In a problem that involves an object going up and down, at the top of its peak it has a velocity of 0, and each point on opposite sides of the parabola have the same velocity with the opposite sign.
This is how you know the final velocity is negative 12 even though you are not given it in the problem.
In this problem, I am underlining the initial velocity they give us of 25 meters per second. I am also noting that they're asking for the time at the peak and the time when it hits the ground. To start this problem, I am writing out my variables and filling in my givens. Now look at your kinematic equations and decide what equation would be the best to solve this problem. For part A of the problem, you want to use V equals V initial plus AT. There is only one unknown, so you can plug in your variables to find time at the peak. For part B, you just have to multiply your part A answer by 2, since the time from the ground to the peak is the same time from the peak to the ground.
You know, I'm amazed, fine. I don't care. I'm sorry. And listen, you guys, you pick the date because I really kind of threw stuff. Here.
Initial velocity of 6
You want to do 16?
and peak of its path.
Equals 1/2 AT squared plus V initial T plus D initial, and it's D equals 1/2 times 9.8 times 0.12 squared plus 6 times 0.612 plus 1.5, and then D equals 3.34.